In this video, I'll be going through our notes on inscribed angles and polygons. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So notice that this is not an angle that is a central angle. Last class we looked at the angle ACB and we would have said that's a central angle because its vertex is the center of the circle. And we said that if that angle measure was 135 degrees, then the arc AB would also be 135 degrees. However, now we are looking at the inscribed angle. So its vertex is on the circle and the sides are both chords. So we have a chord DA and a chord DB. Those are chords because they do not go through the center, so they can't be diameters, but they are two points on the circle that are being connected by that segment. So it is a chord. The intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So the intercepted arc of this inscribed angle would be arc AB. So our inscribed angle theorem states that the measure of an inscribed angle is 1/2 of the measure of the intercepted arc. So for example, if the intercepted arc was AB at 100 degrees, that would mean that the angle ADC, the measure of that angle, ADB, this angle would be 1/2 of 100. We would just say that that would be equal to 50 degrees. So the central angle was equal to the arc measure. The inscribed angle is 1/2 of the arc measure. So we're going to apply that to some of these examples. If you think you're able to try it on your own, go ahead and solve it. Pause the video and press play when you're ready to check. First up, we are looking at this inscribed angle x, and we're given that the intercepted arc is 126. So to solve for x, we're just going to divide by 2, so we get an answer of 63 degrees there. Next up, we are told that the inscribed angle is 32 degrees, so the arc must be twice that, so we're going to multiply by 2 and get an answer of x is 64 degrees. Here, this angle 2x should be equal to 1/2 of 108, that intercepted arc. So our equation becomes 2x equals 54. We would divide each side by 2, and x would equal 27. In our next example, we are given that we have the arc NM as 160 degrees, and we can see that NL is a diameter. So since NL is a diameter, we know that NML, this arc, would be a total of 180 degrees because it is a semicircle. So if we take 180 and subtract the arc that was given to us, NM, of 160, that leaves us with 20 degrees as this arc measure for LM. Well, if the intercepted arc is 20, then the angle N, this inscribed angle, needs to be 1/2 of that. So angle N would be 1/2 of 20, which is 10. So the measure of angle N would equal 10 degrees. Then we are told that we need to find the arc measure of WX. I can see that I have one arc for XY as 110 and an inscribed angle of angle WXY as 75. So since we know this inscribed angle is 75, the arc WY would be 2 times 75, or 150. So to find WX, I'm going to take 360, which is the entire circle, and subtract the 2 other arcs that I'm not using. And my difference there would become that the measure of arc WX equals 100. This would be 100 degrees. And our last example here is the measure of arc QR. So QR is given to us here, and we don't know anything about that arc measure. What we are told is that this line segment, TR, is going through the center P. So TR is a diameter. That means that this is worth 180 degrees. And we also know that this inscribed angle right here is 50. So since this is 50, then the minor arc QT would have to be twice that amount. So we know that QT is 100. The major arc TQR actually is a semicircle because it is touching the endpoints of the diameter TR, and therefore QR must be 80 because 100 plus 80 would make that full semicircle of 180 degrees. So the measure of arc QR would be 80 degrees. Next up, we are going to look at a corollary to this theorem. So the corollary to the inscribed angle theorem states that if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So you can see in this picture, or this diagram here, that we have an angle ACB, where C is on the circle, so it is an inscribed angle, and its intercepted arc would be the arc AB. We have another inscribed angle, angle ADB, and we can see that that also has an intercepted arc of AB. So they have the same intercepted arc, and if these two angles are congruent, which in this case they are, then they are going to be, those arc measures would be the same. So since AB was the intercepted arc, that means that ADB and ACB, those two measures must be congruent. So in this first example, I meant to change this, just should be find the measure of angle ZXW. And this letter over here was a W. So I want the angle ZXW, which is right here. So I can see that that is an inscribed angle with the arc ZW. I have another inscribed angle with the arc ZW. Since they are sharing the same intercepted arc, then those two angles must be congruent. Since we know the measure of angle ZYW is 72, then that must mean that the measure of angle ZXW is also equal to 72 degrees. Feel free to pause the video and try the other two on your own. In this one, we're asked to find X. We can see that we have an inscribed angle with this arc and another inscribed angle here with the same intercepted arc. So based on our corollary, since those arcs have been intercepted, those two inscribed angles must be congruent. So we can say since they have to be congruent, we can set them equal to each other. 5x minus 2 will equal 4x plus 9. We can subtract 4x and add 2, so x equals 11. And here, same idea, we've got an inscribed angle of 3x plus 5, and it's on this intercepted arc. We also have this inscribed angle of 80 degrees on the same intercepted arc. Since they are sharing the same intercepted arc, they must be congruent, so we can say that 80 must equal 3x plus 5. Subtract 5 from each side, and we're left with 75 equals 3x, and when we divide by 3, we're left with 25 equals x. So we're going to use this to help us come to some conclusions for what would happen if the intercepted arc is a semicircle. So here in this diagram, we can see that this angle, this inscribed angle, it's sitting on the circle, so let's call it A, B, C, and it's on circle D. We can see that BC is going through the center D, which means BC is a diameter. So if BC is a diameter, then we know that this intercepted arc of arc BC is going to be 180 degrees because it is a semicircle, it's on that diameter. So if that's 180 degrees, then the inscribed angle, remember, always has to be half the measure of the intercepted arc, and therefore this must be 90. So what we can come to a conclusion of is that the angle formed, the inscribed angle that is formed when the intercepted arc is a semicircle, will be a 90-degree angle. The triangle that's formed with the diameter is going to specifically be a right triangle, and the hypotenuse of that inscribed right triangle is a diameter of the circle. So we're going to use this to try some of these examples. If you think you can figure it out, you may pause the video and try them and press play when you're ready. Otherwise, keep listening along and check your work. First example, we have circle P, and we can see that AC is going through the center P. So AC is a diameter. That means that PC is a radius, and PC is 11, so AP must also be 11. Therefore, to find the length AC, we would just add the two radii together, and we get a total of 22. That means that my length of AC is 22. Well, since this is a diameter, I know that my intercepted arc has to be 180 degrees because it is a semicircle, and therefore this angle B, the inscribed angle here, must be half of that, so it is 90. I have a 90-degree angle in this triangle that is now formed. I was told that the hypotenuse of this will be 22 because I got 11 and 11 together. And I have this one angle down in the bottom right corner of my right triangle of 23 degrees. So what I can do is use that information to figure out a little bit more of this circle. So to find BC, that chord, I can see that it is a side of a right triangle. I already know the hypotenuse, I know an angle, and I now want the side that is next to the angle, so the adjacent side. So if I know an adjacent side and a hypotenuse are working together, then I can use the cosine of theta equals adjacent over hypotenuse. So I'm going to bring back my trig here. Cosine of 23, because that is our theta angle there, will be equal to our adjacent, which is what we're solving for, x, over 22, which is our hypotenuse. We'll multiply by 22 on both sides, which leaves us with 22 times cosine of 23 for our x value, and when we round that to the nearest tenth, we are left with 20.3. And that is going to be equal to our BC value, so 20.3 here. It's smaller than our hypotenuse, so that seems like a reasonable value to get there. Then we're asked to find the measure of arc AB. AB is the intercepted arc for the inscribed angle that was given to us as 23. So since the inscribed angle is 23, to get the intercepted arc, I need to multiply by 2, which leaves me with 46 degrees. For the arc BC, I already know that this arc was 180. I just found that this arc is 46. So in order to find the remaining, I would take 360 and subtract the 2 that I know. So 180 minus 46, and take that away from 360, and I'm left with a total of 134 degrees. Finally, my arc measure of AC, well, that's just connecting the other side of my diameter, so it's just another semicircle of 180. In my second example, I'm asked to find other parts of this circle, and I can see that AC is again a diameter of this circle M. So that means that because this is a diameter, arc AC is a semicircle, and if that is a semicircle, then that means that the inscribed angle that it shares an intercepted arc with must be half of 180, which is 90. So I have another right triangle sitting here. The measure of angle BAC, I can see that I have a 90-degree angle, and I know that the intercepted arc for the angle BAC is 120 degrees. The inscribed angle must be half of the intercepted arc, so half of 120 would be 60. And now I know that this angle A is worth 60 degrees. So to find BC, I can see that I have AB was given to me as 7. I just found the angle A, so to find BC, I have a couple options. I could either use trig or I could use a special right triangle. Since this is 60 degrees, this is 90, that leaves me with 30 here. And in a 30, 60, 90 triangle, remember, we learned this, that across from the 30 is always the side that is worth 1, the hypotenuse is worth 2, and the side across from the 60 is always worth root 3. Well, since I already know my short side across from the 30 is worth 7, then 2 times 7 will be my hypotenuse, which would be 14, and 1 times root 3, or 7 times root 3, would be my length of BC, so I would get 7 root 3. You could also use trig here, but I'm using that special right triangle to save me a little bit of work. So I just found those two sides. And then finally, I'm finding the measure of arc AB. AB was this arc over here. We can see that it is the intercepted arc with the inscribed angle of 30. An inscribed angle is always half the measure of the intercepted arc, so the arc of AB would be 60 degrees because that's 30 times 2. And for our measure of arc AC, we can see that that is touching both sides of a diameter, which means that would be a semicircle, so 180 degrees. Finally, we are left with our inscribed quadrilateral theorem. The inscribed quadrilateral theorem says that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So by inscribed in a circle, we mean that all of these angles must have vertices on the circle. So all 4 vertices of my quadrilateral can be inside of this circle as long as those opposite angles are supplementary. So that means that D plus F must equal 180, and E plus G must also equal 180. They need to be supplementary to one another. They don't have to be congruent necessarily, just supplementary. So we're going to use that to help us solve some of these. And I would suggest working backwards. So if you'd like to try them on your own, go ahead and pause, start over here with this third one, and then we can move backwards there. So in this last example that we're going to do first, we have angle Y, and it should be supplementary to this angle 87 that is across from it if this is inscribed in a circle. Since this is an if and only if statement, that we know that since it's already drawn inside that circle, then that must be true, that they have to be supplementary. So I'm going to add up my Y plus 87 and say that those two added together must equal 180. I'll subtract 87 from both sides, and I'm left with Y equals 93. To find my X value, I do a very similar process and say, well, 2X and 100 must be supplementary because they're opposite one another in an inscribed quadrilateral in a circle. So I'm going to take 2X plus 100 and set that equal to 180. Subtract 100, 2X equals 80, divide by 2 on each side, so X will equal 40. We'll do the same idea in the next one. Since this is a quadrilateral that is inscribed in a circle, then those opposite angles must be supplementary. So we'll take 4Y plus 5Y, set that equal to 180. 9Y equals 180, divide by 9, and we are left with Y equals 20. And in our second set of opposite angles, 2X and X plus 12 must be supplementary. So 2X plus X plus 12 should equal 180. 3X will equal 168 when we subtract 12 from each side. Divide by 3, and X will equal 56. And finally, for this more challenging one, and this is why I wanted to save this for last, we can see that we've got a few different angles given to us, but not all of them are. All we know about the opposite angles in a quadrilateral inside or inscribed in a circle is that those opposite angles need to be supplementary. So I'm going to find this last arc because some of the information that's given is that I have an arc JM of 54 degrees, an arc ML of 130, and an arc LK of 110. So if I want to find the arc JK, I just have to take all of those and subtract from 360. So my difference when I subtract those three arcs from 360 is 66 degrees. So that's going to actually help me figure out some of these values. So what I'm able to determine from that is that these two arcs, so the arc MJ plus JK, form the arc MK. So 54 plus 66 is a total of 120. And if all of that is equal to 120, then what I'm able to say is that 3A should be half of that arc. So 3A would be 60. So I can say an equation would be 3A equals 60. Therefore, if we divide by 3 on each side, A should equal 20. Then what I can figure out is that because this is going to be 20, if this is 60, the opposite angle must be 120. From there, I can find my other variable, B, by doing a similar process and saying, well, this angle is touching this intercepted arc. And so the intercepted arc of JL is 66 plus 110, so a total of 176. And since that is a total of 176, half of that is going to be what our angle 4B is actually worth. So half of 176 is going to get us 88 degrees, and therefore this arc up here must be 88 degrees. So we have 4B should equal 88, and if that is the case, B equals 22. And if that is worth 88, then this last angle must be 92 degrees because 88 plus 92 are supplementary.